Hey gang, today we're going to continue our work with graphing using slope-intercept form, what you developed all of last week. All linear equations are written in the form y equals mx plus b, or y equals b minus mx, where m is the slope and b is the y-intercept. This is called slope-intercept form. Slope is defined as the rise over the run, somehow that's missing there, which gives the steepness of the slope, or the change in y over the change in x. Remember, not all solutions to the line will fall on the corresponding coordinate planes. Prove a point will be on a line by substituting it into the equation and checking that it works out. So let's see what we got. Graph the following. So we have a very simple equation. If you remember from last week, this is what we call a proportional relationship because the y-intercept is 0 and is going to fall through the origin. Since the y-intercept is 0, we're going to start at 0 and the slope is 1/2. We're going to go up 1 over 2, up 1 over 2, up 1 over 2, and so on. Then down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2. Take your straight edge, draw a nice straight line through the function. That's why we call it a linear function. Arrows on both ends. And label it with the equation, y equals 1/2 x. So as I said before, there are infinite solutions to this equation. So we see a bunch that fall right on the line. We want to prove that one off the line or off the coordinate plane also satisfies the line. So to do that, we're going to substitute it into our equation. So this point 30, 15 tells us that the x is 30 and the 15 is the y. So in our equation, we're going to make 15y equals half of 30, and half of 30 is 15, proving that it is a solution. And if our coordinate plane was much bigger, it would be on the line. Let's take a look at the next one. Okay, so here again, we have y equals 1/2 x minus 5. So we have the same slope as what we had in the last one, but we have -5 as our y-intercept. So if we start at our y-intercept down at -5, 5 below the origin, we would go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2 one more time, and down 1, left 2, down 1, left 2, down 1, left 2. And again, all of these points on this line are solutions to the equation. I can prove it if I pick one random one, say this one right here, that's point 2, -4. If I plug it into my equation, -4 is the y, equals half of 2 minus 5. So that's -4 equals half of 2, which is 1, minus 5. So -4 equals -4. It proves that it is on the line because it is a solution to the equation. Now, we want to prove that this other point is also on the line and a solution to the equation. So again, the 28 would be the x and the 9 would be the y. So we have 9 equals 1/2 of 28 minus 5. So 9 equals half of 28, which is 14, minus 5. So 9 equals 9, proving that that point would also be on this line if our coordinate plane was much larger. Now you see those two graphs side by side, and hopefully you're noticing that if we were to merge those two graphs, these two lines, the one in the last and this one, the 1/2 x and the 1/2 x minus 5, would be parallel lines. Now they're parallel lines because they would never touch and they're going to run next to each other at an equal distance forever. That means they have the same slope. Makes sense that parallel lines have the same slope. They would be running on and on forever next to each other, but would never cross. Okay, number 3, y equals x. Now, this is a tricky one. In this case, it looks like nothing's really given, but actually, the y-intercept is given as 0. And the slope is 1. How do I know that? Because there would be an invisible 1 right here. That x by itself means that there is 1x. So my slope is 1 or 1 over 1. So now I'm going to start plotting those points. We start at 0, go up 1 over 1, up 1 over 1, up 1 over 1, and so on repeatedly. And down 1, left 1, down 1, left 1 repeatedly. Take your straight edge and draw your line. Arrows on each end, and label it with the equation. Now you'll also notice that if you went through and looked at those actual points, every single point has an equivalent value of x to y. So this point right here is 1, 1. This point right here is 3, 3. This one up here is 6, 6. And if we went in the opposite direction, this would be negative 4, negative 4. And so it makes sense that the equation is just y equals x because the coordinates are the same. All right, taking a look at number 4, similar slope to the last one because there's no number in front of the x. So the slope once again is 1 or 1 over 1. And the y-intercept this time is positive 4 because of the plus 4. So we take our y-intercept at 4 and then go up 1 over 1, up 1 over 1, up 1 over 1, or down 1, left 1, down 1, left 1, down 1, left 1. Then use a straight edge to connect the line or connect the points, forming a line, arrows on both ends, and label it with the function rule. And again, all the points on this line would satisfy that equation. So this point right here, for example, is 0.28. And if I were to plug in 8 equals 2 plus 4, actually I did that wrong. It's not 2.8, it's 2.6. See how I knew that was wrong because 2 plus 4 does not equal 8. And 2 plus 4 is 6, so the point checks out. So again, all the points on the line would be solutions to that equation. Let's keep going. All right, so for number 5, we have y equals negative 2, 6. Now, hopefully you're noticing that that negative sign right away tells us that we're going to have a negative slope instead of a positive slope. So our y-intercept, once again, would be 0, and our slope is negative 2 over 1. Remember, whenever it's a whole number, you put it over 1. All right, so now we can start to graph. We would start at 0, and instead of going up 2 and over to the right 1, we're going to go down 2 and right 1, down 2 and right 1, down 2 and right 1, making a negative slope. If you were looking at this from left to right, it would be going downhill instead of uphill like it does when we have a positive slope in all the other problems. Arrows on both ends, label it with the function rule. And again, all the points on this line would satisfy that equation. So if I take a look at this one right here, that is point negative 3, positive 6. Let's make sure I did that right this time. Yep, it is definitely 6. So if I plug that in, 6 equals negative 2 times negative 3, and that is correct. So we know it is a solution to the line. All right, next one. Again, we have a slope of negative 2 because of this minus sign in front of the 2x. So our y-intercept now is 3. Our slope is still negative 2. So we are going to start the line at 3, then go down 2, right 1, down 2, right 1, down 2, right 1, or up 2, left 1 to follow the pattern. Draw your line nice and straight, arrows on both ends, and label it with the function rule, y equals 3 minus 2x. And once again, if I pick any point on my coordinate plane, it will satisfy that equation. So if I go with this point right here, that is 0.4, negative 5. I can plug it in. Negative 5 should be equal to 3 minus 2 times 4, which is negative 5 is equal to 3 minus 8. And again, 3 minus 8 is negative 5, so it works out. Now, one more time, I didn't bring this together before, but if we were to merge these two graphs, those two lines would be side by side but never cross. And again, that's because they have the same slope. An equation or two equations with the same slope are what we call parallel because they are increasing and going over at the same rate, but will never cross. Okay, so think of slope as creating parallel lines. Okay, so you're going to complete 7 through 10 on your own or with a partner. Please make sure you're checking in with me before you move on to your exit ticket and your homework.